user, but let's hope so. The possibly the safest way because of lots of in-between buffering and very accurate position syncing retrieval. We are able to retrieve the syncing very accurately, or, well, in most cases. We had a problem with Beyond when I first was developing the synthesizer that a certain vendor of sound cards didn't return. When you're playing a sound, you normally would expect that when you're having a next sync point, you would expect it to be bigger than and yeah, it doesn't happen sometimes. So you have to hack that around. And the only con I came up with is that doing the ring buffer thing on a separate thread is something that if you're a coder who uses GL Vertex 3F, you might have a problem with this. But otherwise, I use this. I would recommend. It also depends on the size issue. It might not fit for 4Ks. That is probably doable, but I think the 4K is still the play sound thing. Now, also, what I'd like to talk about is the actual methods of generating post-processing or generally just getting sound. First thing is you probably all know general MIDI. It's ringtones, website, background sounds, and all the horrible, horrible crap of the internet. The good thing is that it's a consistent sound quality. It was meant to sound good. It doesn't need any setup or anything like fiddling with interfaces or anything, because you have MIDI functions in Windows. You don't have a problem with those. You just send the messages and it plays, which might be a problem if you're not doing a separate thread, that you might fall out of rhythm if your visuals take too much time. And also, one trick which I think it was Frenetic who used it first, or I don't know who wrote the synthesizer for them. I think it was Frenetic. Okay, there's a file in Windows called gm.dls. It's basically a standard setup of MIDI sounds. Now, what you can do is load the file, take out parts, actual instruments, actual high-quality, good-sounding instruments, and use them as samples for basically anything, XM files, or just playing them back, render a big wave, do whatever you want. It's always really high quality, and it's always there. The problem with general MIDI is that you probably don't want a 4K which sounds like your friend's ringtone. That might be some kind of a turn-off for people, because it's rather repetitive sound. It's the same sound you heard in websites, the same sound you heard in maybe other 4K intros which you don't even like. And what also might be a problem is that there's no guarantee that the sound card someone else has doesn't re-implement the GM.dls and basically alter the samples. So you might have different samples. But it's been popular in 4Ks. As far as I know, the 4Ks listed there are using that. And also some post-processing. So they load the samples and filter them, add some delay, stuff like that. Probably the first synthesized method for synthesizers for music in intros was precalculated sampling. This works in a way that you have a synthesizer, much like, if you remember, Orangeator. It was, I think, released by T-Rex, a Russian group. So a great synthesizer. It was like, I think, 300 bytes for a sample. You could tweak all the kind of little parameters and have a really decent sound. And what you could use in your intro is include the data file, include the synthesizer itself, parse the data file, and generate the sound blocks you later will need in your intro itself. Fmod actually has mini Fmod, which is a real popular XM replayer for intros, actually has a callback which enables you to ignore the samples in the actual XM file and load whatever you want in it. It's a really simple callback. This was the first thing I did. If you saw Project Genesis and the Place Called Universe, we used that method. I'd like to show the synthesizer which was used. It's not a good memory of us because, well, it worked, but yeah. the essential concept was somewhat simple. You have 10 oscillators, each one different waveforms, envelopes, filters, and the final sound was something like this. Now, we were able to basically add like some kind of sequence to play little acid loops and filter them with resonant and low-pass filters and have some envelope. It was really, really basic. It was sort of my first try on a synthesizer. What we would do with this is that we were able to save these files in files like this and later parse them to a binary. We kept this because we didn't want the format changes to affect our working process in case I had new features. And it also had an XI export. So if you sort of like change up the resonance and export a wave file, you can basically load a custom tracker, open the XM file itself, and here you have it actually. Oops. This way you were able to construct a whole module, a whole song, with just simple sounds, or, well, depending on how much time you spent on the actual samples, simple, or even we were able to do drum sounds because I implemented frequency envelopes. It was basically one generator for everything. It was a really cheap concept, so it kind of worked, well, even though I'm not really proud of the end result. The good thing about it was that the sound quality was decent, considering that it was basically the cheapest approach. You probably saw all the intros listed up there. They all use the same technology, probably just being the most famous about it because it was the first. It was, as far as I know, a complete 303 emulator. There's no CPU needed because you just mix the samples. Probably you're using some kind of a tracker format. You also can use the actual tracker effects, like bending the pitch down, volume slides, whatever you want. And you can, the good thing also is that most musicians are able to use trackers. So you don't have the problem of, okay, now you have to use this for intro music, and they won't like it anyway. The downside is, if you start to have more and more samples, it takes more and more memory. So even though it's not as much as it might sound, you can go to up to 5-6 megabytes without a problem. Still, if you're having a problem with your memory consumption, you might not want to use this method. Also, it increases the loading time, but that also depends on how fast your code is. But also, since you have to pre-generate everything before, then you have to fit somehow that loading time also into the time frame. And if you already have like 5 minutes of loading, then you might not want also this method. And this is more an artistic problem. It forces the use of same samples throughout the song because you probably can't get the musician to render another instrument just because of a slightly same sound. They just pitch it up or something like that. You will eventually get bored of the same samples going throughout the song. But this is basically artist stuff, and it depends on the musician. Probably the most interesting method is the real-time generation. I'm not sure. I think it was first used in Totraum. The trick is to render the sound as you play it. Have some kind of a synthesizer which doesn't work in a fixed type of memory, but always additively uses its memory and uses buffers in case of like feedbacks and all that stuff. The good thing about it has real sound quality. It's natural. It's very, very free to use. And there's no pre-calculation needed. You just need to load it. You have all the freedom you want because if you want just to change something, change up the pitch, or change up a cutoff filter, you don't have to render another version of the same baseline again just because you want the filter to be changed. You can change the drums on the fly. You don't need 5 or 6 drum samples to have some kind of a Goa-ish tweep or something like that. It's somehow familiar to trackers, but I think the best thing about it is that it's really, really small. You don't need processing. You don't need anything to think about when you do the replay. You just call your generators, call your FX, you mix them, and you're done. And it also, the problem, you have linear data because when you're storing your music data, you usually store streams instead of trackers, which they store in per roll fashion. Now the problem is, you can actually change that, but the way the linear data works, that when you usually bend up some kind of value, like you turn the card off and stuff like that, it's usually something really, really good, gives a good compression if you use delta coding, because it only takes small steps. Now the problem with it is that you have an extreme CPU load because everything is rendered during when you're rendering your animation, you're rendering your 3D scenes, and it takes some skill to code. Excuse me. But yeah, this is probably the most popular way of synthesizing sound nowadays, as the intros show, basically. Now, I also coded something like this. Let's hope it just works. I used Buzz. It's a really hectic program, but one can get used to it. What I did is having several set of machines and sort of relying them to create an effect chain. Now the good thing is about, as said, the artistic freedom is that if I wanted the drums to, or a lead to be changed, I can just do it on the fly. I don't have to like re-render the whole sample or render or add another instrument which might fit or might not fit. I can hear everything on the fly. It's a really, really easy method. Buzz has the problem of being under-documented and under-trustworthy. Now, also, you might want to extract the data from it, and that's a bit hectic because the file format isn't too documented either. It has some quirks. You can also code a VSTI or some kind of plugin for your favorite MIDI sequencer. And the last method, which is probably the best usable for 4Ks, is algorithmic music. Algorithmic music is really hectic. It's the smallest method available because there's no data, there's no processing. It's just code. You create the music from your code. When you want a drum line, you do a for loop. Now this is evil, yes. Now, then again, you can code anything. You don't have to like have restrictions. Oh my God, I don't have a distortion, or I can't add distortion to that, or I want to loop the effect chain backwards. You can just do your code whatever you want, the way you want. It's your code. You can interchange it as long as it's small. Now, since it also uses probably the method of rendering the whole song at once, very, very long precalculation time, insane amount of memory used, and the only tool you have is Visual Studio. Now, speaking about tools, there are a couple of applications you can actually use, which you don't have to write for yourself. Applications such as trackers. There are probably a good amount of Windows trackers available at this point. Scale, Renoise, Modplug, Schism, you name it. It's preferred because it's the traditional scenish way of tracking. It's been around since 92, 93, or even early on in Amiga days. Everyone is used to it. Everyone can use a tracker. Even most commercial musicians were trackers once. And the trackers are freely available, so there's no problem with getting one, actually. So you probably can easily... Excuse me. You can easily get one of the trackers. You have no problem with that, and it's just something you don't have to code. You have to be lazy. You don't need to code your own graphical user interface just because your musicians want to. Here, have a tracker, have the synthesizer work. You can use also sequencers. The problem with that is that there are not many really good MIDI-compatible sequencers available freely. There's obviously anything VST compatible or VSTI compatible can be used, such as Logic or Nuendo or Sonar, Cubase, whatever. But they're mostly for money. Now, if you don't have moral problems, you're basically set. There's also Z-Tracker. Z-Tracker is, as far as I saw, an impulse tracker clone rendering into MIDI. It's somewhere between a tracker and a MIDI sequencer. I haven't tried it myself yet, but I've heard it's really good when you want to use this method. The good thing about VST and VSTI is it's very, 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 very widespread. A lot of documentation, a lot of enthusiasts, and a lot of plugins to compare to. Now, the good thing in that is that you can adjust your sound to your favorite plugins. When you're having a plugin, you can feel you could code somewhere comparable. You can always dump down the sound, like remove filters, remove all the oscillators, and then slowly develop your plugin to the sound, and finally have something which might be close or even better to your final result. And another method is that algorithmic trackers don't really have a tool. Visual Studio, what you see there is an actual music code. It's kind of hectic, and it's coder music. Now, musicians probably don't want to learn to code just because you want to have a 4K, which is why I decided that this is not the way to use music, because how it works is you render into a WAV file, and you also you don't just have the time you have with a sample generator, like tweak, export, or render, export, load. You also have compile, build, crash, all the funny things. Now, I decided to be a bit more innovative than that, and sort of did a kind of a hybrid method between code and trackers. It was a joint venture by me and TSV of Epilepsy and Umlaut Design. It's called the Klangzeug. Now, yes, if you take a look at the actual interface, you might notice that it's a complete ripoff of every tool I saw ever. It's basically, yes, this I hope it's not patented, is it? The overall concept of the tool is almost like Buzz. You have generators, you have FX, you have a sequencer, you have things to twiddle about, you have patterns to write to, stuff like that. The actual difference is that this exports code. It optimizes on the fly and exports an assembly code, which is probably the most compact method to actually have final music, which you don't have to like write on every for loop and all the arrays and stuff like that. You have the code, it works. All you have to do is compile it. And I'd like to demonstrate the sound. It is actually some sort of a remix of a probably well-known commercial track. Okay, so did anyone recognize it? Yes, a man with no name teleport. As can be heard, it has a rather good sound because it's essentially a 303 emulator. But I didn't limit myself to certain genres. So Now the footprint of actual this music compiled with everything is around 1,100 bytes. So I think that's a rather good ratio compared to what you would achieve in most today's 4Ks. The actual method of creating music is really easy with that, because you have all the little tweaks you need, just like anything else, and you can export the assembly code. Or actually, we have a version that the problem is that during the development phase, the things get a bit hectic, and we have two versions. One of them works, and one of them can export. So you have yes. So what you get is a final assembly file with all the loops optimized and the sound data included, almost the same way you would have it when you code it. It's just that optimizing can be automatic, and you don't have to bother to re-render. If you want to test a lead sound or something like that, you just enclose it buzzway, mute it out. You can test the sound easily. That's the good point in it. It's really compact, but on the other hand, it's really nice to use. And also some generic tips and tricks about how to optimize your sound. Don't compromise on the sound quality. Most 4Ks nowadays could have better music, but a little bit more filtering, a little bit more reverb, more delay. Don't compromise. You can take those extra 100 bytes. You can always optimize that away later. Very basic effects are mostly really good. I mean, you have a delay sound, and it gives a depth to your sound. One problem with Klangzeug is that it's mono. I decided to ditch stereo because it takes a tad more processing and obviously much more space in the memory. So I decided to ditch stereo. It doesn't have stereo effects. But the advantage of being mono is that you can work on buffers on the way. So you don't have to think about two separate channels. There are three important things to consider size-wise. How much does your data cost? How much loading do you need to actually get the data into sound? And how much code do you need when you're replaying the sound? With assembly play sound, the replay code is really small. The data with Klangzeug wasn't big too either. I mean, you had the sequences, you had the patterns, all the rest was code. The loader code was where the size was. But the problem was, if the loading code is too big, you won't be able to fit. So if you generate a really optimal code, you won't have a problem that way. There's something I haven't really seen in 4Ks, and that's compression. And I don't mean MP3 or the likes. I mean mastering and expansion and things like that. It's like 2 lines of code, but it makes a difference between your actual sound. I can actually show you how it sounds without mastering. And then if I put the compressor back, you have beef in the sound. Many people ask me what compression was. Compression is basically something like an audio engineer looking at the peak level, and when it turns too hot, it turns too loud, it turns it down. So basically, if your sound is above a level, you damp it. You don't clip it, you damp it down. And then you can amplify it much more. You get the lower sound regions much more louder. It's more fat. It's more thick sound. It's actually, I mean, if you have a big sound system, now normal demo parties have big sound systems. You want your track, even if it's a 4K, to sound strong and good. Mastering is 30 or 40 bytes of extra code, and it helps. It does help. One of the problems, what I saw in 4K sounds, is that they sometimes tend to repeat the patterns over and over again. The problem with that is it's not needed. additional 16 bytes, which are usually having the same notes or the same sequence, compress away into 2 or 3 additional bytes. You don't have a problem with that. It's the machine setup and the actual synthesizer which is big. When you want to add variation, do it. You don't lose anything with it, especially with drums, where you actually just need like a byte with bit flags saying where should you have the kick drum, snare drum, whatever. Always compare with your system. And when you're making a synthesizer, there are always other bus machines or other VSTs or other commercial tracks to compare to. It's a really good idea to have some kind of idea what do you want. Whether you want something that sounds a bit more acid or something more electro. You can, every synthesizer has a feel. Even basically the sequencers itself, if you listen to Reason, you can actually after a while recognize music made with Reason because it doesn't have extensions. It has the same setups or same machines working. Every synthesizer has its feel, its sound, its atmosphere. So all you have to do is choose one and try to reach that. Mine is more having acid, 303 distortion. 303 was basically the concept I wanted to go for. And since 303 itself isn't hard to emulate, I think it works rather well for other synthesizers as well. And also, something more artistic is that when you're a coder coding a synth, you often run into the thing that your musician isn't having fun when composing because it just doesn't sound right. You have to be a bit musical when coding audio. You have to use your synth. You have to feel your synth. You have to play around. You have to have fun with it. If you don't have fun, then your synth isn't perfect for complete usage. Then again, if you don't like music, you probably shouldn't code audio. So you have to have that mind state of okay, and now I want to make sound. But I think it's a really, really good idea to just load your favorite Buzz plugin, just code it into Buzz and trying to make a song. It will probably be coder music if you haven't touched music software before. But then again, it's worth a try because then you can feel the quirks, hear the audible things like your synth is clicking, and you can remove the overhead of the musician complaining about things like that. Everyone who likes music thinks about songs like, okay, I want to reach that type of reverb and stuff like that. Am I that bad? Oh. Okay, so the bass concert will be 10 minutes later. Anyway, guys, this concludes. And if there's any questions or any other ways to humiliate me, then go free. Oh, it smells bad. So, any questions? Go ahead. Excuse me? Could you just... So, yep. Physical modeling. It's possible, obviously, but I didn't touch DSP right now. KB had a really great DSP seminar at Breakpoint. You probably should watch that instead. I'm trying to avoid DSP, for one, because it's probably easily acquirable, and for two, because I suck at it. Now, if you want physical modeling, no one prevents you. What I'm trying to say right now is how you get sound out and how you should build up your synthesizer structurally when you want to have the data and anything like that. So physical modeling, nothing prevents you from doing that, actually. It's just that I chose a 303 as something to achieve. Anything else? In that case, let's go and watch the 4K compo.